Well, good morning. This is 9:38, 8 minutes late getting started. Tuesday, the 27th of April, 2017. Supposed to be Math 113, Pre-Calculus Trigonometry, and unfortunately, I'm the only one in the room. Don't know where everybody is today. Usually, people are here by now, and they're not yet, so I'll have to go and get started. Let me go over just end of the term logistics before we get going. Okay. First and foremost, please do your student course evaluations. They've been open for a while now. You don't have to do them until the end of the term, but if you're likely to forget them at the end of the term, do them now. Please do the student course evaluations. I value them because I see them and use them for my personal improvement. But also, I see them for the instructors under me because I have to evaluate them, and that's part of their evaluation. And the various offices, things like admissions, registration processes, library, I don't know, food services. I don't know what all they ask, but there's various things around campus. They also ask about maintenance or something like that. Those people, sometimes it's the only or the major form of feedback with them. We get to talk with you every day, the instructors. They don't. So please do the student course evaluation. It is important. We value them. Okay, so that's first. Number two, all your research papers are due today. And let's see, for this class, and only two people have turned in research papers. So please, those are due today. After today, you start losing points. All right, number 3, I guess. Tomorrow, my normal office hours on the Birmingham campus would be 7:45 to 1. However, tomorrow I've got to leave a little early. I don't feel bad about it because, hey, thank you for being here. I hate talking to myself. I feel like I'm losing it. Okay. So... What's that?
The stuff that you make for me. I have my thing.
Oh, good.
And my thing is on stage.
Oh, excellent. I was just fussing. Only 2 people have turned it in. Now 3 people have turned it in.
And my take-home test. And I have my work behind it.
Okay.
Or I'm going to put it inside of
Put it
it.
inside of it. That's what I was
Because
thinking.
I'm not confident about this test at all.
Okay.
And so you should see what I'm doing.
Okay. All right. Good deal. Thank you so much. Okay. I was just going over, I've already started Screencast-O-Matic and that kind of stuff. I was just going over logistics, timelines, and things like this. I was saying that your papers are due today. You've got it in. That's good. Today's regular class day, the last one for regular term classes. So after this class, my office hours are 10:45 until 1:15. 1:15, I've got a class with second mini-term physical science class, and we will be there probably the whole time. Maybe we'll finish a little on the early side, but no guarantee of that. Tomorrow is I'm scheduled to be on the Birmingham campus. I will be there, but normally I'm there 7:45 until 1, but tomorrow I've got to leave about an hour early, okay? Now, number 1, I've been late here every night this week, so I don't feel bad. They've gotten their pound of flesh out of me this week, so I'm not worried about that. But I may have to leave a little early. I do have to leave early because my wife is flying to Amsterdam tomorrow. Poor gal. She's got professional meetings there all week from Friday till Friday.
Does she not get to go sightseeing?
What's that?
Does she not get to go sightseeing?
I think she has 1 or 2 evenings that she gets to do a little bit. Yeah, she'll get there a little on the early side. They've got a tour or something planned for that, and maybe a little bit tomorrow. I think the meetings, let's see. Yeah, she flies out, and I think she gets there, Saturday morning, even though she flies out this evening. And then she will, I think she has sometime Saturday, but then I think the meeting starts Sunday, And I think there's one other time they have, so she'll have sometime Saturday and sometime later in the week that she'll get to see a little bit. The rest of the time she's going to be in the hotel doing meetings, so she's got something like 4 poster papers and 1 presentation, so she's going to be occupied basically all week. Okay, but anyway, I won't be there past 12 or much past 12 tomorrow. The next week, for regular term classes are final exams, so there won't be any classes. However, I do have a second mini-term class. We have class on Tuesday and then the final on Thursday. So, except for that. But Mondays and Wednesdays, both of those classes, I mean, all 4 of those classes on those 2 days are just like this class. I give them take-homes because those are Cal 1, Cal 2, linear algebra, and differential equations. The tests take way too long to do in class. So, they have take-homes, so I won't be in class Monday or Wednesday. I'll be in my office 7:45 till 5:15. Unless, of course, someone comes by to do makeup work. And if they do, then I find the classroom closest to my office to do the makeup in. That way I can go back and forth to my office without having to leave so long. And also maybe even hear the phone and get to it before it quits ringing. So, okay, the one I'm going to give you today, in fact,
it'd be Thursday because our class
yeah. Technically they're due on Thursday, but I'll take them any day next week.
I was just making sure, like, when was it actually?
It was scheduled for, the final would have been scheduled for Thursday, 9 to 10:50. Okay, so anytime Thursday, Friday, Monday, Tuesday, or Wednesday. I don't care. Oh, yes. I'm going to put a tardy down here. I can't stand this, you being late every day. Okay.
I've never been late. It's my first time.
I know. That's why I said
The
it.
doctor called me yesterday. He's torn all the way after that surgery.
Yeah.
Yeah.
Is it going to be arthroscopic or is it going to be the big stuff?
I don't know the difference. He didn't tell me.
You didn't?
He said just reconstructive, so whatever that means.
Okay. I don't know either. Okay.
I mean, it's just a kind of.
They're going to cut it up. Yeah.
2 scopes, and they have to connect it to both bones.
Okay.
Tibia to tibia.
Okay.
Can you turn it in right now?
What's that?
Stuff.
If you want to, I'll take it anytime. Okay?
Got lots of stuff.
Yes. Saving all my grading till the end. Thank you very much. I appreciate it.
You're
Big time.
I mean,
Yeah.
I'm always going to correct something.
Okay.
Correction it to pass.
All right.
That 4 bonus points for that essay at the beginning of the year didn't encourage me.
Obviously. Okay. Okay. But I maybe those, if they're late negative points, that may have encouraged you a little. Okay.
Yes, and I don't think.
Okay.
I have confidence that my essay will get a 100. So.
Oh, wait. I'm sorry. Slap him. He's dreaming. I'm sorry. He's asleep. No. Okay. Huh?
He said slap me.
No.
Yeah, that's what he
Yeah,
said.
because he's asleep. He's dreaming. He needs to wake up. It's class time. Okay. As I was saying, I don't know if I said this one yet or not. I said it before you came in. Please do the student course evaluations. Are they done already or not?
No.
Not yet.
I'm
Please
working
do.
all
Good.
because
Excellent.
I'm not a procrastinator.
What are they gonna do if I don't do
Okay. Nothing. No one's going to do anything, but you just don't get the input
Yeah, I get
to
bonus points
make
for one.
changes, you
it?
know.
I don't get bonus points for any of that, and that's
I
like
get bonus points in 2 of my
that's
classes.
10 evaluations
That's
for
what.
me. I have 10 evaluations.
Well, you see how valuable you are. We value your input big time.
It's gonna take more than 2 minutes.
Okay. Yeah.
One of them took me 30 minutes to do, and that's because it kept asking the same question. It wouldn't go on to the next question.
If you were so stubborn, you wouldn't do it, would you? No, I'm just kidding.
No, I don't want to do it anymore. It's irritating.
No, really, to get feedback from students is really important to us. So, if you don't want a voice, you don't have to. But if you want a voice for change, go for it.
Well, I mean, I'm going to read the questions anyway.
Huh?
I'm going to read the questions anyway.
I read them.
I
Okay.
don't.
Okay.
I don't know.
It's helpful to you. Okay. All right, so please do the student course evaluations. And both people who have come in today have turned in the papers. That's great. That doubled the number that have been turned in by this class. And I was talking about today's a regular class day, so we'll go till 10:45. I have office hours 10:45 till 1:15. Then I have class from 1:15 till pretty close to 5:45. We may finish a little early today, but I can't guarantee it. They do have a test last part today, so they'll probably finish a little early, but not too much. Tomorrow I've got office hours on the Birmingham campus, normally 7:45 to 1. Tomorrow I've got to leave shortly after 12, maybe a little before 12. I've got to take my wife to the airport, and they have wanted to be there 2 hours early, so I've got to leave early tomorrow. So don't come around at 1 expecting to find me. Okay, next week is final exams week for the regular term, but not for mini-term. We still have class next week. So on Monday of next week, I will be in the office basically Mondays and Wednesdays, 7:45 to 5:15.
So for midterms, the final is supposed to be that next week?
No, the last day. Actually, they have it on the schedule as Friday. So a student doing all mini-term classes has all their finals on Friday. It's ridiculous. It's crazy. So I give my final the last Thursday.
Yeah,
The Tuesday, Thursday class, I give it on
my
Thursday.
biology just giving us hours Tuesday.
Okay.
And I didn't know that they did it like that.
They're not supposed to, but
No,
If
like,
you're finished
I didn't
with
know
it.
that if they were all pushed back into a Friday.
well, the reason is the mini term's supposed to be an 8-week term, but you see we only have 7 weeks in finals, so basically you lose the week if you don't have class that last week. On the first mini term, you have a 8-week term, except the last day of class is your final exam. So they need to do that but you see that's not finals for everybody else. First mini term. But here, finals for everybody else is scattered over the whole week. Theirs really should be the last day of class. However, they actually have it on the academic calendar as second mini-term finals on Friday. That means if someone already had a Friday class, then they have to take that one and their mini-term class. And then there are conflicts. They could be on different campuses. It could be a pain. So I give mine on Thursday, the last day of class. If it's Tuesday, Thursday class, I give the final on Thursday.
Well, let's do some math now.
Okay. Let me cover the rest of it. I'm in the office Monday and Wednesday all day, 7:45 to 5:15. With the possible exception, if someone comes in to make up a test, then I go to the nearest empty classroom to my office. So usually that's 263, 256, 261, 254, or 259, or 257, or this room. This room's always available, so I may be in here if I'm not in one of the others. Okay? Tuesday, I have a math 112 final in here, 8 to 10 basically. May actually go a little longer because that class is a large class and usually they take a little longer to finish. So I'll be up here most of Tuesday morning. Then I'll be back in my office, but then at 1:15 we have the last class for my mini-term class. Now it won't last a full 4.5 hours, okay, because there is no lab that day. And there is a test, but it's going to be a fairly short test. So I'll probably be back in the office, I'm guessing 3, 4, 5, somewhere around in there. Okay, I'll be here till 6 o'clock that night. Then Wednesday, I've already said. Thursday, the only thing I have is the 1:15 or 1 o'clock final, or they may come in at 1:15. It will be over by 2 probably. Okay, so I'll be in the office the rest of the time. Friday, I'll be on the Birmingham campus. This is the finals week Friday, and I'll be there 7:45 to 1. Now, grades are due. We have to have grades in by noon on Wednesday of the week after finals. So don't start looking for your grades before then. But, what's that?
So I'm going to expect.
Okay. But what I was just going to say, if you are looking for them, look on Blackboard, because you will not be able to access Student Suite during finals until grades are put in. Because if you are looking, we can't get in. There's only like 16 portals for the whole system. And if 16 students are looking for the grades, no instructor can put in their averages, put in the grades. So they block students the last.
We can still check on Blackboard.
You can check on, that's what I'm saying, check on Blackboard. I'll put them on Blackboard first, then I'll put them on the portal, and then after that next Wednesday, sometime Thursday or Friday after the grades are in, then you'll be able to access them through the student suite. Okay, now also that next week, we've got to leave town sometime Thursday because we've got a family graduation down at LSU. So we'll be driving down Thursday for the graduation on Friday. And are either of you graduating? Okay. If you were, I was going to say I'll miss your graduation because we'll be driving back Saturday and won't be back in time to graduate.
I was graduating.
Okay. Okay. I think that's it. Any questions before we get going? All right. We were going to start example. Well, this is still set on example 1, and the reason it's on example 1, example 2 is not in the on the slide set. So let's do this. I'm going to use the same figure but change the numbers around. Okay. Let me get my pen activated. All right. Now we're going to have A. We don't know.
Because it's going to just change the numbers since it's the same, like it's still trying.
Yeah. See, example 2, they don't have a slide for it, so I'm going to use the figure they have here, but flip things around. Okay, that's going to make this C and this B. Okay. So this is going to be B over here, and that's going to be 9 meters. And this will be C down here, and that's going to be 12 meters. All right, so that's here. Now, also I want to return all the work you've turned in so far before the end of the day today. You like it? Good deal. My wife doesn't. She said it. I'm not shaped properly for this kind of shirt. Something like that. Okay. All right, good deal. Thank you. Was it, did you have to get a drive?
No, I restarted my computer and it won't work.
Okay.
It was just being difficult.
Okay.
Thank
It
you.
was because I was in the room. Though.
Yes.
Okay. Okay. So that's our problem here. It says find the, okay, this time it's not 3 angles. It's find the remaining sides and the remaining angles and the side of the triangle. Okay? Oh, one more piece of information. A is equal to 25 degrees. Yo! Okay. All right. 25 degrees. All right. That's what we've got. How would we go about solving that?
Well, it gives you an angle and it wants all the other angles. So you just do it like maybe do I had a thought. Because we're doing all of this one.
It's going to be law of cosines. The reason you can't do law of sines, with the law of sines, you have to have an angle and the opposite side. Here you have an angle, but you don't have the opposite side. Here we have a side, but not the opposite angle. Here we have a side, but not the opposite angle. Law of sines will not work in this case. In the law of sines, you've got to have at least one ratio complete. This one you don't. Okay? So therefore, law of cosines. Now, law of cosines can be written either one of 2 ways. Remember the way that would fit this one. What would you be looking for first here?
Be looking for the other side.
The other side, exactly, A. Okay? And you remember how that goes. Law of cosines.
Sine of big A equals B squared.
Okay?
C squared
You said the cosine of big A is equal to what?
B squared.
B squared
C squared
plus C squared
minus A squared
minus A squared over, say again, 2BC. Okay, exactly right. And here's how I remember this. Everything's plus here except the square of the side opposite this. And that's B squared plus C squared, A squared, and there's no A down here. Just the B's and C's. Okay, so I think we can go for it. Wait a minute. That's if you're looking for the angle. What we're looking for is the side, though, so you have to use the other form of this. Yeah, it'll give you, it gives you the angle, but the other one's already set up for you. Okay? And just undo this. Multiply both sides by 2BC, and then add this to both sides, subtract that from both sides, and you have A squared is equal to B squared plus C squared minus 2BC cosine A. That's the form that will give you the answer most directly. You can plug and chug there, but boy, you got a lot of messy numbers scattered all over the place. If you write it this way, you find A squared, take the square root, you got it. So let's try it. What would that be for this problem?
9 squared.
Which is 81 plus 144 minus 2 times 9 times 12 times the cosine of 25 degrees. Okay? Crank away. You will need calculators. It's not something you can do in your head. I can do that in my head, that in my head. I could even sort of do that in my head. But cosine 25, I don't carry around.
It'd be cool if you do that, Brandon.
What's that?
That'd be cool if you do that, Brandon.
No, it wouldn't. I'd be freaky. All right. Andrea is here. Now, again, let me go over a few things. So a few of you came in later. Please do the student course evaluations if you haven't already. Okay? And you got another paper. Excellent. Okay? And I will be giving you before we leave today. I went by this morning to pick them up. I turned in the test to be copied last night before I left, and this morning when I came in, she hadn't copied them yet, so right at the end of class, I have to go down and get them. Okay? But anyway, just don't leave without them.
The answer is 122.6.
Say that one more time.
122.6.
122.6.
That is not the answer.
Okay? That's because you haven't taken the square root yet, have you? And that would be meter squared, because you squared B, which is meter squared. You squared C, which is meter squared. B times C is meter squared. When you take the square root, what do you get? A is equal to, approximately,
11.07.
let's just leave it 11, okay? Approximately 11 meters. Does that make sense?
That's still not the
No. Okay. Well, it doesn't make sense, does it? Because 25 is, it looks like pretty obviously the smallest angle here. If this is set up to scale, so this should be the shorter side, that should be, and that's longer than B. And it sure doesn't look like it should be. Let's see. Let's step through it quickly. 9 squared plus 12 squared minus.
Do you do all that before you do the multiply by cosine?
Okay. You do 81 plus 144 minus 2 times 9 times 12 times cosine 25.
Yeah, I didn't do that.
Okay. calculator not working?
I'm still not getting the right answer.
What'd you get?
This time I got 10.
Okay, I don't have a calculator with me, so I can't do it.
I have it in degrees.
Okay. Let me make sure I wrote down the numbers right. Yeah. 81 plus 144 minus 2 times 9 times 12 times base times 25. You're in degree mode? Yeah. Okay. That should give you an a squared, and then you take the square root. Actually, the square root of 10 would not be far off. Did you take the square root?
Yeah, I took the square root of 101.
Oh, okay. Well, a bit on the big side.
29.23.
Say again?
29.23.
Is that with the square root or without? Okay, then take the square root. $29.23 should be 5 point something.
5.40.
Okay, I'm trying to find where they have that in the book.
That's wrong. It's in the book.
Yeah, 5.40. So I would say that's about 5 meters. Okay, but hang on to the 0.40 for 5 point. Yeah. Okay. That gets you a little bit of the ways there, right? That only gave you one side. You still got 2 angles to go. How do you get the 2 angles? Law of sines will certainly be helpful. Now, I would keep as many digits as you have there, so hold on to it before you erase those. And what do you have the law of sines? You tell me how it looks. No, okay, you could do law of cosines. No, you can't. You have to use law of sines. Because you see, now you have a ratio that's complete. You have the A and the sine A. To do law of cosines, you would have to have either one more angle. No, you could do law of cosines. You sure could. Because you have the 3 sides, and you could get the other angles for that. So yeah, you could do law of cosines, but that's a lot of squarings and subtracting and taking square roots and stuff. Law of sines is a little easier. It's just a ratio, proportion. So what would be your ratio? Give me what the law of sines is. Oh, please, you've done all this homework. Say again? Okay, sine B over little b is equal to sine A over little a. Okay. Now, in this case, we're looking for, we know little b, we know little a, or we calculated it, and we know capital A. So we're looking for sine B. So let's solve for that. That would be sine capital B is equal to the product we know, which is b sine A divided by little a. Right? In other words, multiply both sides by b. So, let's plug and chug. B we knew was 9 times the sine of 25 degrees they gave us. And now here's where we have to plug in the A. I would not use 5, even though I said round off to 5. I would use whatever is on your screen, okay, which at least is 5.4072. If you have more digits, use them all. Okay? All right. Okay. So if you'll punch those numbers in and tell me what you get. See, with law of sines, there's no squaring. It's all a simple ratio, proportion. Okay. 0.70345, is that what you said? That's the sine of B. Is that a reasonable sine? Why? Yeah, it's between basically 0 and 1. Technically between -1 and 1, but you never have in law of sines a negative sign. Okay, so it's between 0 and 1. So take the, how do you get from there to B? That's what sine of B is. How do you get what B is? Sine B is equal to this. How do you get what B is? Inverse sine, exactly. Inverse sine of 0.70345 or whatever you got. Say again? 44.75 degrees. Let's just round that to 45. So that's angle B, 45 degrees. Now, at least in the drawing, that looks reasonable. Okay? We had our A to be approximately 5, though we use more digits than that for our future calculations. Now what do we do? Law of cosines or law of sines?
Well, all we're doing is looking for the angles. Why can't we just do 180?
Absolutely, that was the correct answer. Okay, that was the trick question. Okay, so yes, all you do is add those two together, which gives you 70. Subtract from 180, and that makes the C what? 110, 110 degrees. Very good. Okay, of course, they carry all sorts of extra digits around that are basically unjustified. And so I said 5 meters. They said to 5 significant digits. They don't have it. I said 110. They said 110.3. And we said, whoa, no. Yuck. Okay. All right. They did 2 possibilities there. When they did that first one to get sine B, they come up with 2 different answers. But that shows B either 45 or something greater than 45. Greater than 45, that's going to be your largest side. Side B is shorter than side C, which is 12, so it can't be that one. B's got to be acute. So they did a lot of extra work there. So they said 44.7, I said 45. And we got it. But you do have to check that and make sure you're consistent. Okay? You've got to have, the other way they were going to do this was have this being an obtuse angle. If that was obtuse, that would have made B longer than C. But it wasn't. B was shorter than C, so if any angle was obtuse, it had to be C. And it turned out being obtuse. All right, good deal. There is a checkpoint there, well worth a look. Okay, this is all that previous problem. And we did that one, didn't we? That, I think that was all example 1. We finished that, right? Okay. Okay. Still, they call this an introduction. Do you see why it was y in example 1? Did we go over this? I think we did, didn't we?
Yeah.
Okay. Well, then we got. Okay, applications. Here's example 3. The pitcher's mound on a women's softball field is 43 feet from home plate. There they have 43 feet. Now, they do some weird way of initialing, but that's fine. Okay? There is a reason for it. And the distance between the bases is 60 feet. So it's 60 feet here, 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 and here. Now, what they don't tell you they show you in the picture, all the bases are 90 degrees. Okay? These are all right angles here. All right angles. That's what they didn't say, but their picture showed that. The pitcher's mound is not halfway between home plate and second base. If you thought it was, think again. Okay? It's a little further back. And they show that here. Okay? So how far is the pitcher's mound from first base? So basically what you know this side, they gave you this side. Now they didn't give you any angles, but if the pitcher's mound is exactly halfway between first and third, which of course it is, then you know that is going to be a 45-degree angle. If this is 90 and this is halfway between, this has to be 45. So again, we have a side angle side situation. Okay. Now, have you figured out why they did F's and P's and H's? Yes, exactly. They did the sides opposite those three places. Okay. So, what we're looking for is, what is it? How far is the pitcher's mound from first base? We're looking for the H, and only the H. We don't care about anything else. So how do we get it? How do we get it? Think law of signs will help us?
Yeah.
Nope.
Nope.
Why not?
Because we don't have any rings.
We do not have a completed ratio. We have an angle but not a side. We have a side but not an angle. And we have another side with no angle there. You've got to, for law of signs, you have to have a completed ratio. So since you don't have that, what would we use? Law of cosines. Now how does that go since we're looking for H? H squared is equal to? Little f squared p squared minus 2f p cosine of H. Is that what you said? I couldn't hear you. Yeah. Big H. Oh, big H. Okay, yeah. And we know what that is. It's 45 degrees. We even know what the cosine of that is. So this is going to be f squared, which is 43 squared. I'm not going to do that in my head. Plus, I can do this in my head, 3,600 minus, I'm not going to do this in my head either, though I probably could. I don't want to. 2 times 43 times 60. And I do know what cosine of H is. Cosine of 45 is the square root of 2 over 2, right? Okay, so I can wipe out those two 2's right there. And now is a rather simple way to get H squared. Punch away.
I got a question.
Yes.
You said that we cannot use sine because why?
Because you do not have a ratio, a completed ratio between an angle and its opposite side. See, you have an angle here, but you don't know that side. You know the side here, but you don't know that angle. You have the side here, but you don't know that angle. For the law of sines, you've got to have one ratio complete. And then you can set it.
And it says 43 squared plus 3,600.
Right, that's 60
minus
squared.
2.
Yeah, but I wiped out the 2 because I knew cosine of 45 degrees was square root of 2 over 2.
So
You do that too, didn't you?
yes.
Yeah.
Plus 3,600, then 40 times 43 times 60.
Times the square root of 2. That's all minus, minus all three of those multiplied together. 43 squared plus 3,600 minus 43 times 60 times square root of 2. Equal. punch all the numbers in if you want to, and let your calculator do them, that's fine.
1,800.
Okay, and then what do you got to do with that?
Take the rear.
Okay, so this is 1,800. Wait, 1,800, okay, right? And then you take the square root of that, and what do you get? H is approximately equal to 42 feet. Feet. Okay, does that make sense?
Yeah.
Yeah, it does. Because this is 45. That's just less than 90. Just a little bit less than 90. So this is probably a little bit greater than 45. Maybe 46. So this side should be a little longer than that. And sure enough it is. Yeah. So 42 feet approximately is what you got. They say 42.43 feet. I'm sure those grounds crew have that stepped off to the nearest hundredth of a foot. It'd be a fraction of an inch. Okay. There is a checkpoint there, which also has to do with a softball. So I'll let you work on that. All right. Let's see how they did it. In the triangle HPF, that's home pitcher first, H is 45 because the line bisects the right angle between first and third. So that's got to be 45 degrees. F is 43, we've given, and P is 60, was given. So the law of cosines is the sassy case here. All right, here she is. Leah is here. Okay. Stomach says it's lunchtime. It's not. Okay. Okay. So we're on example 3 on page 413, section 6.2 in chapter 6. So h squared is f squared plus p squared minus 2fp, law of cosines, cosine h. That's 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. They came up with 1800.3, very close to what y'all did. Take the square root. So approximate distance is the square root of that, which is approximately 42.43 feet. How in the world do they get 4 significant digits out of something that gave you no more than 2? They can't. So approximately 42 feet. All right, good deal. I don't think they do example 4, so let's step back and do example 4. Okay? What we have here is a ship travels 60 miles due east. So the ship is starting here and travels 60 miles due east. Okay? Then adjust its course as shown below. And they're showing this is an A and this is a B. And they don't give you any angles or anything else. They just show you that C is up here 80 miles from there to get to C. After traveling 80 miles in that new direction, the ship is 139 miles from the point of its departure. So we know this right here is 139 miles. Okay? Describe the bearing from point B to point C. From B to C. What is the bearing there? Okay? In other words, what is this? You're going to have to find that angle first. That's not going to give you the bearing. You're going to have to get that later. You need to find that bearing. That angle first. How do you reckon you do that? Law of cosines. And how will that run? Cosine B equal A. Say again? Oh, okay. We can go on and do it. This is our little A, this is our little C, and this is our little B. So 80 squared, you're absolutely right. Plus 60 squared. Minus Okay, 130. Okay, 139 squared over 2 times 80 times 60. All right, absolutely. That's the law of cosines, where the only time you use that is in the minus 2 squared. I think hopefully you'll look at that and say, this is going to give me a negative number. If you haven't, you'll find that out soon enough. All right, and here is EJ. If I can find you, there you are. Good deal. By the way, the law of cosine says that the cosine of the angle you're looking for is the square of the sum of the squares of the sides on either side of that angle minus the square of the side opposite that angle divided by 2 times the product of those two.
My overall answer, including the
Cosine.
inverse cosine, is 166.
166. Say again?
166.15.
166. Let's just round it to that. 166 degrees. Now that's not your bearing. That's what the angle is. How would you define the bearing of point C from point B? Well, with bearings, you always consider north-south, and you're always so many degrees either east or, well, you give the north-south. This one's north. So you'd say it's north, how many degrees from to the east? Okay, now you know this is 90 degrees here. So what would that be? 76 degrees east. North 76 degrees east. What did they get? They used 0.15. Who cares? North 76 degrees east. Again, you can't get more precision out of the problem than you had given in the problem. All right. There is another checkpoint with that one. Okay, that's just what bearings, how you define bearings. Bearings are always taken from either north or south. Since this is on the northern half of your hemisphere, you go to the north, and how many degrees toward the east. So it's always north so many degrees east, north so many degrees west, south so many degrees east, south so many degrees west. That's how you define bearings. And it's from the point here to the point there. So this is where you draw your north-south line. This one shows you the north. If you go back, what was it? Huh?
This is just something that you didn't know.
Well, haven't we done it already this term? It may have been last. No, I don't think it would have been.
4.
I think it's, yeah, in chapter 4. I just can't see it in the title. It's probably in Applications and Models, 4.8. Let's see if it was back there. 4.8. Yeah, trigonometry and bearings. Page 332. Yeah, 332. Bearings are always given from either north or south, so many degrees east or west. And there's the picture that we were using. Basically, the I don't have a figure number for it either.
That shows what I was paying attention to in section 4.
Oh, I see. Okay. I understand now. Okay. All right, that was example 4. Now we're ready for good old Heron's formula. Now, back when I was in school, I don't remember which, it was high school or college, they used to call this Hero's formula. But then someone figured out they misspelled his name. But for the longest time, I called this Hero's formula. I think they mention it somewhere here too, but maybe not. Okay. All right, Heron's area formula. The law of cosines can be used to establish the following formula for the area of a triangle. This is called Heron's formula after the Greek mathematician Heron, who lived in the era of 100 years before Christ. This is way back there, 1 century before the birth of Christ. Way back there, he had figured this out. Given any triangle, okay. Now remember the area formula we used last time. You had to know a side, and the angle in between. Who can measure angles? I mean, very confidently, especially in big areas. A little protractor doesn't do a very good job. That's not an easy thing to do. But guess what? Everybody can measure lengths. If you got a tape measure, you can measure the length. So that's what Heron's formula does. Given any triangle and you can measure the lengths, A, B, and C, then the area of that triangle is given this way. Wait a minute. What in the world is S? It's called the semi-perimeter. Semi means half. Half your perimeter. So what you do, you add up your sides, A, B, and C, divide by 2, that's your semi-perimeter. The area is then the square root of the semi-perimeter times the difference of semi-perimeter inside A, difference of semi-perimeter inside B, difference of semi-perimeter inside C. Okay? Pretty simple formula came up with way, way, way back in history. More than 2,100 years ago. Okay, a long time passing. 2,200 years ago, in fact. No, not quite. Okay. So here we have, find the area of a triangle having these three sides. 43 meters, 53 meters, and 73 meters. I don't know if that's right or not. 43 meters, 53 meters, that's probably not drawn to scale, and 72 meters. Okay? What's the area of that triangle? And by the way, when I randomly draw a triangle like this, it almost always looks like it's a right angle. It's not. Don't count on it being. I just drew things down. For some reason, mine always look like they're close to being right angles. They're probably not. Okay? How are we going to do this? What is that area?
First, you got to get your S.
Okay, and what's your S?
A plus B plus C over 2.
43 plus 53 plus 72 over 2.
That equals 84 and all.
And that's what?
84.
84. Which is pretty nice because you take the square root of that 84, and that's in meters, times 41. 84 minus 43 times 31. That's 84 minus 53 times 12. Okay? Now notice here, your semi-perimeter is always going to be greater than any one of the three sides. If it wasn't, then you're going to have a minus in there. And can we take square roots of minus numbers? No. So, someone with a calculator, punch away at that. Say again? I can't hear you.
This might be the easiest thing we've learned in here.
Yeah. All of it's easy. Okay? What do you get?
I got 1,131.88.
Is that when you took a square root?
It surely is.
Okay, 1,000 what?
131.88.
32. Let's call it 1,132, and that would be square meters, because each of those sides was a meter. And the units make sense too. This would be in meters, that would be in meters, that would be in meters, and that would be in meters. That would be meters to the fourth. When you take the square root of it, you get meters squared. So sure enough, that's right. And let's see how good the book did.
Sure enough.
Oh, they're going to show it in a minute. So let's, yeah, 1132 square meters. All right, I'm going to erase my scratch unless someone has a question about it. And then what they did, because S, the semi-perimeter, is the sum, the perimeter of the three sides, divided by 2. Semi means half. That gives you 168. Divided by 2 is 84. Then Heron's formula is S times S minus A times S minus B times S minus C. Square root of all that, you get 84 minus 43 times 84 minus 53 times 84 minus 72. And that's the square root of 84 times 41 times 31 times 12. And that would be approximately 1132 square meters. Very good. All right, you have now studied 3 different formulas for the area of a triangle. We didn't study them, but you should have known the area was 1/2 the base times the height, which we used with the oblique triangle once we knew the height was C sine A or B sine C, or whichever combination of those you are. Then you have these 3 areas for oblique triangles. If you know an angle and 2 sides. See, most of the time in a triangle, you can measure a base, but figuring out the height is not that easy. You can estimate it, but figuring it is not easy. This one, you'd have to know an angle. You can measure the 2 sides, that's no problem, but finding the angle is hard. In Heron's formula, though, all you have to do is measure the 3 sides. Those are pretty easy to measure. Then find that semi-perimeter, and then use the formula. Make sense? Okay. So practically, Heron's formula is the most useful. Okay. The others, if you happen to know the H, first one's really easy. If you happen to know 2 sides and the angle in between, somehow you knew that, then those are not bad. But if all you know is the 3 sides, which are really easy to measure, Heron's formula is the one to use generally. And this connection with the law of cosines is that 3 sides will give it to you. Okay. Actually, your oblique triangle there, it just happens to be you use the sign, which you used in deriving the law of sines, but actually you know the 2 sides and the angle in between, which is normally what you use for law of cosines. But this is sine. All right. Vocabulary. Well, let's see. Make sure that's the last slide. It is. Vocabulary on page 415. When you are given 3 sides of a triangle, you use the law of blank to find the 3 angles of the triangle. Cosines. When you're given 2 angles on the side of a triangle, you use the law of cosines. Yes. To solve the triangle. Okay? I'm sorry. And it says any side of a triangle. 2 angles and any side of a triangle. That is law of sines. He was right. I've misread it. Okay. 2 angles and any side of a triangle. Why is that true? What if you knew these 2 angles here, the angle here and here, but you this side down here? You don't have the opposite angle, do you? Yes, you do. Add those 2 together, subtract 180, and you got it. Okay? So, yeah, you do know it. So, if you have 2 angles, you got 3 angles. That's the key to that one. Okay, number 3. The standard form of the law of cosines is cosine B is equal to A squared plus C squared minus B squared divided by 2AC is what? They just gave it to you. The standard form of the law of cosines for cosine B. I'm not. Okay, here's what they're asking. Here's what they're asking. If you go back to page 411, you see the standard form is the one in one line without the denominator. So what they're asking for is B squared equals A squared plus C squared minus 2AC cosine B. That's what they're asking for. And then the law of cosines can be used to establish a formula to find the angle of a triangle called blank blank formula.
Aaron's area.
You got it. Homework exercises here. Do any of the odds 5 through 11. They gave you pictures, and any of the odds 13 through 23 with no pictures. Then do any of the odds 25 to 29. They gave you information there. You fill in the blanks that you don't know. Then any of the odds 31 to 35. Any of the odds 37 to 43. And then any of the applied problems 45 through 59. You pick the ones that are most important to you. There's some explorations, true, false, number 61. You could think about that. And then look at the others. You could prove some stuff if you want to go there. All right. Let's see what we can get done in the next section. Okay, 6.3. This is pretty important stuff, folks. I wish we'd have had time to do it, but you'll have plenty of other opportunities because many courses go over this. But let's hit as much as we can while we can. Since y'all are in trig, does that imply that some of you are going to take some physics? Yes, you will be. You will be, okay? The odds are you're going to apply it somewhere, and one of the places that's pretty important to apply it is in vectors. Additional topic in trigonometry, vectors in the plane. Yes.
Are you teaching physics during the summer?
I'm listed for 2 of the physics classes. I can't guarantee I'll be teaching them, but I am listed for 2 of them. Yeah.
One of my friends from Auburn is taking a physics class here in the summer.
Fantastic. Yeah, it might happen. Yeah. What were you going to say?
Is this section going to be on the test?
Yes.
Vectors?
Huh?
This vectors going to be on
A
the
little bit. Only what we get to cover today. I mean, I don't know. I don't have the test in front of me, but I believe so. Okay, so let's see what, okay, let's go over it. We'll represent vectors as directed line segments. What do we mean by that? What is a line segment? Well, let's back up. What is a line? Something straight that goes infinitely in both directions. So what's a line segment? No, that's a ray. A ray is fixed at one end and keeps going. A segment is fixed at both ends. So a line segment, by definition, has to have a fixed length. We're going to call that a magnitude later. Length or magnitude. Now, when it says directed, that adds something else to the picture. A direction. So a line segment has a length, but when you say a directed line segment, you know its direction as well. Okay? We'll write the component forms of vectors, which frankly is the way to go. Don't mess around with the other things. Components are the way to go. Perform basic vector operations and represent them graphically. Better not to do it graphically, but it's a good idea to do it so you can get an idea. We'll write vectors as linear combinations of unit vectors. We'll define what those are. We'll find the direction angle of vectors. We won't have time to do all this. And we'll use vectors to model and solve some real-life problems. I wish we had time to. So, quantities, and you find them all over the place in physics. Velocities, displacements, accelerations, forces, momentum, all those are quantities that have not just a magnitude, but also a direction. Force, velocity involve both magnitude and direction. Okay? Now, for instance, I drove here from home this morning. I drove, let's say, about 20 miles. That would be my magnitude, but I drove to the southwest, because I live in Birmingham. Driving home, I'll go the same 20 miles, but I'll be going to the northeast. So you see, that's a displacement, okay? My velocity would be, say, 70 miles per hour to the southeast or northwest, southwest or northeast. It involves both magnitude and direction. cannot be completely characterized by a single real number. Okay? To represent such a quantity, we use what we call a directed line segment, which is called the vector. Now, here's just a general thing about it. A vector, because it has a direction, one point is your initial point and the other is your terminal point, because it's going in a certain direction. The magnitude just tells you how far between them. The direction tells you which is your initial, which is your terminal. So all vectors are represented, or one way to represent a vector is to name it PQ, and if you draw the arrow there, that implies P is initial, Q is terminal. So P is at the point you started, Q at the other point. And we are out of time. So what we're going to have to do, we'll have to stop there. Let me run down, okay? Talk about getting in under the wire. Here's Jasmine, if I got to find which line you're on. And I've got to run down to the copy room, so I'm going to end this and pick up your test.